In this video, we'll use the Eos Switching Station Breaker-and-a-Half workbook to estimate a switching station. This is one of 5 Microsoft Excel design workbooks included with the Eos High Voltage Knowledge Base. Let's start by reviewing the one-line diagram, which shows the design of the switching station. The default minimum configuration includes 3 lines which can't be removed. You can select the voltage for all of the high voltage values. The voltage is preset to 345 kV. The amperage is preset to 3000. Several selections are available. The MVA is calculated and shown for reference. This is a breaker-and-a-half configuration containing 3 circuit breakers per bay. In full configuration, each breaker includes 2 isolation switches which are not shown on the diagram. The first bay is completed with 3 breaker switch combinations and 2 tower-mounted disconnect switches. The second bay contains 1 line with a tower-mounted disconnect switch connected to the bus. Setting the other components in the second bay to future created a ring bus that can be expanded to a breaker-and-a-half configuration. Let's look at the layout for the ring bus configuration on the layout sheet. The second bay just has bus completing the circuits so that a ring bus can be configured. Next, let's add line 4 and the equipment for the line, the tower-mounted disconnect switch, and the other circuit breakers in the bay. This results in 2 completed bays in a breaker-and-a-half configuration. Each line has 2 surge arresters, and CCVTs are provided on each active bus. The layout shows 4 takeoff towers with 4 lines coming into the station. Equipment and connections go along each bay. Each bay has 3 breakers along with isolation switches and cable or bus connections. You can see that the length of each equipment bay is 184.5 feet. The lengths of bay for the various equipment sizes pre-fill from values provided on the calcs sheet. You can change the cable and bus connection lengths, as well as the separation distance from the bus to the control building and the control building dimensions. Everything else calculates or pre-fills from lookups on the calc sheet. For example, separation distances from live equipment to the fence line, between the 2 bays, and between the bus conductors, which gives the total width for the bus runs. You can change the equipment bay sizes and separation spacing on the calc sheet. The cable trench is highlighted in blue for easy identification. The diagram indicates the distances for the control cable for use in developing the quantities. The layout sheet provides plan and elevation views for a typical breaker-and-a-half bay for reference. Let's switch to the quantities sheet. This sheet shows the quantities and dimensions calculated from the one-line and layout sheets. The design results in a 134 by 260.5 foot site. You can see the control building dimensions, cable trench, high and low bus, along with the equipment, including circuit breakers, disconnect switches, and towers. You can add optional overhead shielding mass and wire as needed. Notice the tower-mounted disconnect switches. These are manual switches. The surge arrestor and CCVT quantities are also shown. Some of the equipment requires power and control wiring. You can change the values in the orange and yellow cells. Note that the yellow cells provide handy selection lists. The disconnect switches have quantities for the motor operators if they're required. You also have the option to include them in the model interview. All the quantities and specifications will transfer to the estimate via the model interview in Sage Estimating. When you finish reviewing and modifying the switching station design, save the workbook using a different name, for example, the name of the project. If you make any changes in the workbook, you must save it so the new quantities are available to Sage Estimating. Now you're ready to take off the switching model in Sage Estimating. Select the model that's designed to work with the Excel workbooks and open the model interview. Enter a model reference. This identifies the model on the spreadsheet. Each model must have a unique reference. If needed, you can apply a productivity adjustment for a special area or work conditions that might affect productivity. The model includes graphics for your reference. You can hide the graphics when you're done reviewing them. Next, select the Excel workbook that you completed earlier. As you review the model interview section, you can see the information that pre-filled from the Excel workbook. The voltage is 345 kV and the current rating is 3000 amp. The station doesn't have a second voltage. Some defaults pre-fill for the first voltage connections. The connection type is set to double cable jumper. This could be for 1 to 4 cables, or it could be pipe bus. Wire type defaults to AAC cable. Based on the notes for 3000 amp jumper, you probably need to use 2000 kcmil conductors. Let's put spacers in the assembly 3 feet apart and use compression connectors. Defaults are preset for equipment grounding and control cable specifications. In this case, the default is 2010 substation control cable, which is available on 14 to 9 AWG conductors. Notice that the model includes settings for foundations, which will be applied throughout the model. Moving down, you see 6 circuit breakers preset to gas. Other default information for the circuit breakers is either set in the model or comes from the workbook. The average length of connection between the equipment and the control building is 212 feet for each of the 6 circuit breakers. These settings define the power wiring and the control wiring. The model specifies 1 19-conductor cable and 2 9-conductor cables. Next up are the conduit specifications, PVC and GRS. You can add additional conduit if needed. Review the foundation specs including the size, anchor bolts, and so on. The same type of information is supplied for switches, surge arresters, CCVTs, and takeoff structures. You can select from 7 foundation types for the circuit breakers. The model also includes pipe bus specifications, total length of bus pipe, low to high transitions, and bus type. Based on the note for 3000 amp, you probably want to use 5-inch diameter pipe bus. You can specify other selections for the bus and foundations too. The switching station does not have distribution transformers and switchgear, so let's hide this section. Site development includes trench duct, fencing, and grounding, as well as allowances for lighting and security. Next, review the overhead shielding specifications. And that's the end of the model interview. Let's make sure all the model information is provided by scanning the interview. No incomplete entries were found, so that's good. When you complete the model interview, click OK and then Close. Change the model source to estimate to see the completed interviews. Select the East Orange interview and generate it to the estimate. The estimate spreadsheet now contains all the estimate items. The estimate has pre-selected spreadsheet sequences which are helpful for reviewing the estimate. You can see that the direct cost is $5.4 million and the total cost is approximately $7.7 million. The items are organized by model and assembly. Let's expand the spreadsheet to the assembly level. Notice that numerous assemblies were taken off for this switchyard. This spreadsheet sequence shows items organized by system, activity, and assembly. Let's collapse the spreadsheet to the system level. This shows the estimate subdivided into bus, circuit breakers, disconnect switches, lines and towers, the site, surge arresters, and CCVTs. Within every system, you can see the different activities: the equipment, foundation, grounding, and power and control wiring. Each system has roughly the same activities. To see the details for an activity, just expand it to the assembly level, and then expand the assembly to show the items that make up the assembly. The estimate includes labor man-hours at every level, from the system down to the item level. It includes all of the material costs and any construction equipment needed as well. Note that the equipment columns are not visible in the current spreadsheet layout. All of this detail rolls up to the total amount and grand total amount, which includes allocation of some construction add-ons, so you have a complete estimate. The add-ons include construction overhead and profit, for example, but they do not include engineering or project management performed by others. And that's it. Now you have a complete estimate for a breaker-and-a-half switching station.